So how do you go about paging in exactly what you need? And the answer to that is you do a more exact query. So what I've done here is I've added an index on the date field, which is part of the heating test collection that we added earlier on. And we're going to use that date field and the index on it to do a more precise preheating of a particular part of the data. And the way we'll do that is we'll run a query. We will make the criteria be that the date field is greater than essentially several minutes after I did the initial data load. So I did an initial 200,000 data load and then subsequently did 10,000 more records, another 10,000 for loop. So that's what this is targeting here. So this will load in 10,000 records which have a date field greater than this. That's the criteria. Then we're going to hint, although it would probably pick the date field anyway, we're going to hint that specific index. We're going to hint date 1, and then we're going to do an explain. Here's the output of that explain. You can see that, as expected, because there's 10,000 there, it will have scanned in those 10,000 objects. It'll have scanned through the 10,000 objects in that index as well. So what we've done by running this and running it with an explain is we've managed to touch in all those various different pieces of data, that part of the index. This is quite efficient as well for how the B-tree indexes are actually set up. It's going to be right balanced, it's going to work quite well, and this should basically page in and heat up the correct part of our data. Now, in a practical example, this is somewhat contrived, of course. I've just done this in the last few minutes. But as a practical example, if you knew that most of your activity, most of your data was going to be happening on your last 2 days of data, then you could do a very similar query. You may not have a date field. You may be using the object ID, for example, has a date component to it, or you could be using your own custom field. But all you would have to do is construct a query such that you would be reading in and touching the appropriate amount of documents. So it would be like greater than 2 days ago, that kind of thing. Then you hint the appropriate index that you want that's most frequently used. Perhaps it's more complicated than this, perhaps it's actually a compound index, and then append and explain on the end that makes it run through the entire thing so that it can obtain the timing information down here, which in this case took 17 milliseconds. If you were paging this in off disk, this value would be significantly higher. In fact, just to test that, I have just gone back and dropped the caches here and gone back to a more pristine version of this MongoDB instance. 13 pages of memory, 34 megs, all very familiar to us at this point. And let's see what happens now if we rerun our test. This is, as I mentioned, to page in those 10,000 pages of data and their associated index. Let's run that again. And you can see this time it took on the order of 2.2 seconds. So it took a significantly higher amount of time to run. That's because we'd wiped out the cache, was actually having to page those things in off disk. If you're running a Mongostat there, you would have seen hard page faults happening. So that's what this represents. And if we run our working set estimator and server status again, we can quickly scroll back up. And there you see it. So there are approximately 10k of them. They've been paged in. So this is about what you'd expect, 10,000 pages of memory. The resident memory is going up to 75 megs. So as you can see, that's had an impact. That's paged in the data that we expected there. And subsequent explain back down to 12 milliseconds. So just to sort of prove the kind of impact that can have, there's a more precise way of preheating your data.